Welcome to this podcast on architectural acoustics. In this podcast, we will continue focusing on simulation of acoustics with Pachyderm and Grasshopper. And last podcast, we were looking at how to integrate the geometry and material properties of a Rhino model into our Grasshopper interface and the building of the definition in relationship to computing the acoustic phenomena. And as briefly mentioned in the earlier podcast, we have in our scene here the ability also to combine this with the Grasshopper geometry and specify what layers of our Rhino model that we should pull the material properties from onto those Grasshopper geometries. So what we'll do in this podcast is to simply try and add this in a very simple way to maintain a relatively short podcast here, but to kind of show the logic and the principle. So we need to then create some Grasshopper geometry to include in the scene. So what we can do is we will base it on the model that we already have, or you can model something from scratch, but we will simply try to include or base our chains, our parametric model, based upon the design we already have. So let's say we work from a geometry already in the model. We take one of the walls and include it into our model. And we then want to, basically, one can do many things, but what we'll do here is to simply just try to rotate it using one of the lines here as a hinge to change the opening of the space in relationship between the source and the receiver. So if you then start to model this, so we'll rotate that geometry based upon a pivotal point. Let's see. Let's just turn some of it off to see if we can find where this one is. Anyways, I think it's number 1. We can twist around it. So let's see, we have an angle of rotation in radians, we have the center of the rotation, and we have the axis of rotation. So we want to rotate either on this axis or this here, and we want the center of that. So let's find that. As we can see now, we have here a point that moves up and down, which means we have chosen to rotate around this edge here. And let's just use a slider to rotate it. Whoops. Okay, let's set to -1, 0. And now we can then rotate the geometry in. So now we have a specified Grasshopper geometry in our Rhino model, in our space, that will change the enclosure of this part of the space compared to this part over here. So now we have geometry, Rhino geometry, Grasshopper geometry in our model, and we can simply include this into the component we saw up here. So now we have Grasshopper geometry. But before we start to apply this in here, I think we should just, let's say, turn this off so it doesn't start to recompute. And what we need to also include is then where do we get the material properties from. So here, let's hover over and see, for each geometry in the Grasshopper plugin here, the Grasshopper geometry, we need to indicate what layer by integer ID to copy acoustical properties from. So this means that if we then have a panel, we say we want this from layer 1. Where did that go? So layer 1 we have 0, 1, 2 and so forth. So if you write layer 1, we will pull the properties from this layer, which end effect means we will get the properties that we have specified onto that layer in our Rhino model. So if we then say we want the properties from layer 1 and include the geometry, you see first that it turned red. The reason is that there was a disalignment between the number of grasshopper elements that come in and the number of IDs. So even if you're pulling in 10 geometries and you use the same layer, you will need to specify it 10 times 1, so to say, in order to have a matching ID for each of the geometries that you include in the model. If these two lists are not equal length, you will get an error. Okay, so now, and probably I will turn off the recording again, because this will probably take similar time to the previous podcast. Okay, it has started finished computing, and we'll now see that well, now I don't remember the exact numbers, but basically we will have should have a different set of numbers here, as we now have a geometry in our model that influences the spreading of the sound from the source to the receiver. And by changing the position of this wall, we will again get a different condition. Now I won't change it because we will have the same computation time again, but you will see that the change of the geometry will give us change obviously in the simulations. But this way you can start to combine the grasshopper model with the parametric model. You can of course also just maintain the parametric and create a full parametric model, but basically here you have the possibility to merge between the two environments and to create parametric models in which you can relate to other aspects of your design work than if it was a simple static model as we know traditionally from Rhino. So to just repeat, you will need to include here grasshopper geometry into your scene and specify what material layers you pull information from, and this amount of IDs in this list must equal the number of geometries that is included in the grasshopper geometry input here. Otherwise there won't be a mismatch and it won't compute. The rest of the things we've already looked at. So this was a simple and relatively fast podcast on how to include and parametric modeling in Pachyderm acoustics for Rhinoceros. Thank you for watching this podcast.